Section 5.4, Sum and Difference Formulas. Now, first of all, it is not true that the sine of something plus something else is equal to the sine of the first thing plus the sine of the second thing, or that cosine distributes over addition. If you do enough algebra, you start to get used to the distributive law that says that you can remove parentheses by multiplying things out. But keep in mind that the distributive law is not a rule about how to remove parentheses. It's a property of how multiplication relates to addition. So if this were multiplication, we could use the distributive law to remove the parentheses. But there's no multiplication here going on. This is the sine of two things added together, not the sine times two things added together. If you need further convincing, well, 30 degrees plus 60 degrees would equal 90 degrees. But the cosine of 30 degrees plus the cosine of 60 degrees, well, that couldn't be the cosine of 90 degrees because the cosine of 90 degrees is 0. But the cosine of 30 degrees and the cosine of 60 degrees are both positive numbers that don't add up to 0. So if you can't just distribute sine and cosine over addition, here's what you can do. We have some sum and difference formulas that tell what the sine or the cosine or the tangent of a sum or a product is actually equal to. Now, I'm not going to insist that you memorize all of these, but I do want you to at least remember that they exist so that if you don't remember exactly how they go, you can go look them up and use them. But notice they all have similar patterns. Sometimes there's pluses, sometimes they're minuses. Sometimes sine and cosine get multiplied by each other. Sometimes they get multiplied by cosine times cosine and sine times sine. And I don't know of a really good, easy, enlightening proof of these. I would like to be able to prove them or explain to you why they work, but I don't know of a really good way of doing that that's simple and helps you really understand what's going on. There are proofs of these, but they get kind of complicated. So I'm not going to go into them, but I can provide you with links to other videos or web pages or places where you can see a proof or an explanation if you want to see what that looks like. But we'll just accept that these are true, or we could try them out on a couple of specific examples and make sure they work. Let's try out the sine of, well, the one about the sine of u plus v, where u is 30 degrees or pi over 6 in radians, and v is 60 degrees or pi over 3 in radians. And then when you add those together, you get 90 degrees or pi over 2 in radians. So the sine of pi over 2, we know, is 1. And then the formula says that the sine of, here the u would be pi over 6 and the v would be pi over 3. So the sine of pi over 6 plus pi over 3 should be equal to the sine of pi over 6 times the cosine of pi over 3 plus the cosine of pi over 6 times the sine of pi over 3. So those are special angles that we actually do know or can read off the unit circle what their sines and cosines actually are exactly. So we happen to know that the sine of pi over 6 is exactly 1/2. The cosine of pi over 3 also happens to be 1/2. The cosine of pi over 6 is the square root of 3 over 2. The sine of pi over 3 is also the square root of 3 over 2. And when we put that all together and do the calculations, it does end up equaling the sine of pi over 2, which is 1. So at least in that particular example, we can see that the formula does in fact work. It does give us what it ought to. Here's another example, this time of the formula for the cosine of a sum of two angles. So the formula says that the cosine of u plus v is equal to the cosine of the first thing times the cosine of the second thing minus the sine of the first thing times the sine of the second thing. So here the first thing is pi over 6, the second thing is pi over 3. If you add those together, you get pi over 2, and the cosine of pi over 2 is 0. So if we do all the calculations on the right side of the equation here, we do end up with 0. The formula does work. We can use one of these formulas to find the exact value of the cosine of 15 degrees, which is kind of exciting because up to now, the only angles that we've had exact sines or cosines of have been the specific ones marked out on the unit circle here. There's only been a few angles that we could say exactly, not just a decimal approximation that the calculator gives, but exactly what the sine or the cosine is equal to. But we can use those few that we do know to get some more. The cosine of 15 degrees, for example, well, 15 degrees would be 45 degrees minus 30 degrees. And those are two angles that we do know something about. So we can use the formula for cosine of u minus v is equal to the cosine of u times the cosine of v plus the sine of u times the sine of v. Here the u would be 45 degrees and the v would be 30 degrees, so that the u minus v is 15 degrees. So taking the exact sines and cosines that we do know for 45 and 30 degrees, we can end up with the square root of 6 plus the square root of 2 over 2 as an exact value of the cosine of 15 degrees. What is cosine of 100 degrees times cosine of 80 degrees minus sine of 100 degrees times the sine of 80 degrees? Well, an expression like this, with sines and cosines mixed up this way, looks like the right-hand side of one of those sum or difference formulas. Can you see which one? Which one has cosines together and a minus and sines together? Right, the third one on the list, the one about cosine of u plus v. So here the part of u is being played by 100 degrees, and the part of v is being played by 80 degrees. So u plus v would be 180 degrees. So according to this third formula here, what we have here is equal to the cosine of 100 degrees plus 80 degrees. That is, it's the cosine of 180 degrees, which we happen to know is -1. Now, if you wanted to check this, you could get your calculator and actually punch in cosine of 100 degrees times cosine of 80 degrees minus sine of 100 degrees times sine of 80 degrees. Make sure your calculator's in degree mode, and that should come out to be -1. Okay, here's another expression to simplify. This also looks like the right-hand side of one of these formulas. Can you see which one? Which one has a plus in the middle and cosines that go together and sines that go together? That would be the fourth one, the one for cosine of u minus v. So this mess here is equivalent to the cosine of pi over 9 minus pi over 3. If you get a common denominator so you can subtract, that's pi over 9 minus 3 pi over 9. So that's -2 pi over 9, or because cosine is an even function, the cosine of a negative angle is equal to the cosine of positive whatever. So we could say that's equal to cosine of +2 pi over 9. And that kind of makes sense because up here, multiplication is commutative. We could have just interchanged the pi over 9 and the pi over 3, and then it would have been the cosine of pi over 3 minus pi over 9, cosine of 2 pi over 9. Let's simplify the sine of 1.8 times the cosine of 0.5 minus the cosine of 1.8 times the sine of 0.5. Which of these right-hand sides does this resemble? This time the sines and cosines are sort of mixed up, multiplied by each other, and there's a minus in the middle. So that would be number 2 here, the one for the sine of u minus v. So this expression is equivalent to the sine of 1.8 minus 0.5. That is the sine of 1.3. And then 1.3 isn't anything special, so we'll just leave it as the sine of 1.3. Finally, what about the tangent of 50 degrees plus the tangent of 10 degrees over 1 minus the tangent of 50 degrees times the tangent of 10 degrees? That kind of expression looks like what's on the right side of one of those tangent formulas for the tangent of a sum or a difference. And because we've got a plus on top and a minus on the bottom, it's the first one, the one for the tangent of u plus v. So here the part of u is being played by 50 degrees, and the part of v is being played by 10 degrees. So u plus v would be 60 degrees. So this is telling us that this mess here is equal to just the tangent of 60 degrees. And that's one that we happen to know what it is exactly. The tangent of 60 degrees is the square root of 3.